Today I really wanted to address the idea of functions and how to work with those, because that seems to be a big stumbling block for a lot of people. And I'm specifically going to talk through calling functions and then really explain what parameters and return values are and how we effectively work with those. Let's start with just a very simple example. This is something that it looks a lot like what you guys have been doing up to this point. We have a main function that we are declaring. Inside that we have a variable x that we are assigning the result of calculating the square root, and then we are printing it using a format string, and then we have our main open close parens there. So if we go ahead and run this, send this in the Python folder, and I need to do Python functions. Oh, okay. Okay. I'm going to just do x of 9 to start with then. All right. All right, we'll go ahead and just restart at that point. Okay, so what we have here is something that should look very familiar. We have a definition for a main function. Inside that function, we create a variable, we assign it a value, and then we're doing a print using the .format string to print that value. So if we were to run this in our Python shell by saying python functions.py, which is the file this is declared in, we get the output 9 is 9, which is what's printed here. So let's talk a little bit about what is really happening in terms of starting with this main function. So this is what we call a function definition. That's what the def stands for. It says define a function. And the main is the name of the function. And then these parentheses allow us to add parameters. And we'll come back to that idea. Right now we're not using any parameters. There's just an empty parentheses. And then down here, we are actually doing what's called calling the function. So we actually say, I want to call the function main with no parameters and have it print this value. So let's start by talking about parameters. A parameter is basically a variable. So, it is a variable that only exists within the scope of this body, so only the indented portion that's underneath that definition. That body belongs to just that function, and that's what happens when you call the function. That's pretty much it. So this variable x, for example, we could convert to a parameter by putting it up here in that main. And that means we don't need to declare it anymore. That variable now exists because it comes from calling the main function. But now when we call this main function on line 4, we need to provide a value to be assigned to this parameter variable inside the function when that is actually run. So we would, for example, put our 9 there. So what we're saying now is I want to call method main. I want to pass in the value of 9, which is going to be bound to the x variable, and then I'm going to print that value. This should do exactly what we were doing before. And we get 9 is 9. Now, the functions can be defined by us. They can also come from system libraries, which I know we haven't done much of anything with. But just real quickly, if I import the math library, and this goes back to a question that one of the teachers had earlier is, when we do distance, why are we not using the square root? Well, let's actually do a square root. So here we could say the variable y equals square root of x. So in math.square root, thank you, Josh. Python is not my primary language, so I'm a little slow on some of these. So the math library is what we imported here, and square root is a function defined in that library. And so we just put in the x value that we received from here. We're going to assign the result to y. And down here, we're going to change our print to say square root of 9 is, and then we can put the y there. So if we run this now, we should be actually executing the square root function, passing in that x value, and this entire function call is going to end up being replaced by the result of executing that function. So since this is a square root, we would expect it to be replaced with the square root of whatever value was held in x. Since we're passing 9 in as the parameter x, it should be the square root of 9. which should be 3. Let's see how that works. And you can see there, it tells us the square root of 9 is 3.0. So it did return 3 as we expected. Now 3.0, because math.square-root actually turns it into a floating point number. So even though we passed in an integer, it said, well, actually I want to give you a square root, the square root as a floating point, and that's fine. So how can we write our own functions that give back a value the way that this square root does? Well, let's go ahead and define a function. And we're going to do a really silly one. We're going to sum x and y. So we get x and y as variables in the body of this function. And then if we want to give back a value, we do that with the return statement. So we go ahead and type return. Then we can say x plus y. And that should calculate the value of x plus the value of y. And then that entire value gets returned. So down here, we maybe go ahead and turn our main back into a parameterless method. And we're not going to use math.square-root. We are going to say y equals the sum. So the method that function we just declared of, let's go 3 and 4. And the sum then. And here I'm going to actually do a couple extra slots in this format string and pass in 3, 4, and the y. So this should put a 3 there, 4 there, and a y there because it replaces them in order. So now if we run this, our main function is going to get called. So we're going to execute this function. There's no parameters. We, on the first line, declare y equals the sum of 3 and 4. So we're calling sum, which means we come in here. The 3 gets bound to x. The 4 gets bound to the y. So this is effectively return 3 plus 4. And the return value would be the sum of 3 and 4, which would be 7. So this entire sum call is now replaced with the value 7 as y. And then we go ahead and print it, and that's going to throw the y out. And we don't need the of 9 in there anymore. Okay, let's see what that does for us. You can see there that we got the sum of 3 and 4 is 7. Okay, so that's what a return does. There are a couple other things you may have seen. So you may have seen, for example, pass. This is a keyword that basically says, I haven't written a body yet. That's all it is. It's just a placeholder. And this is actually something I had not seen until this class, because a lot of times we immediately write our body. We wouldn't need to use this. But this is basically a placeholder saying at some future point I'm going to come in and add a body. And it needs to be there because of the way that Python code is actually interpreted. If there's nothing in the body, that's considered an error. So this is something we call a no-op for no operation. It doesn't actually do anything. But I did have some teachers ask about that. That's all it is. And if we were to call a function somewhere in our main, that will come in here. It will see the pass, and it just will do nothing. So it really doesn't affect anything. Like I said, it's a placeholder. It allows us to have that there as part of our function until we can come back and add the missing pieces. Now let's talk a little bit about some of the patterns that you've seen in your homework. A lot of your homeworks are now starting to ask you to write a function to do something and take in some arguments. So for example, we might say, write a function sum that takes x and takes 2 values and returns the sum. This is what you would do with that. Now, if you want to get that from a user, we could actually ask for an A and a B and get those from the user using that input function that you've used up to this point. So please enter a number, and let's give it a colon. And then because we want this to be a number, we need to wrap it in, and Josh, help me on the syntax. Is it number or float? To convert it to a float. Oh, yeah. Just float, okay. And we don't need this function anymore. We'll just take that out. and then we'll say C equals the sum of A and B. So now down here when we're printing, we could actually replace this 3 and 4 with our A and B variables, which we get from the user, and then the Y we're going to replace with that C, which is the sum of the two. So when we get a request for writing a function that returns a value, this is really all it is. And oftentimes they're not going to be very big functions. And a lot of times we'll actually move the inputs into the main or into another function. And we can do this as many times as we want. We can go as many functions deep as we want. It can get confusing when you start doing a lot of layers. But basically what we're doing here, we should ask for the two inputs. We calculate the sum using that custom method we just wrote, and then we print the value out. So enter a number, let's say 5 and 10, and the sum of 5 and 10 is 15. So this is kind of a pattern you're going to see. Depending on what the homework tells you, sometimes the inputs should just be placed in the main. Sometimes they might be put in the actual method. But the real value of writing a function like this is that that function now can be reusable. For example, at one point you guys were doing an interest calculator where you're calculating compound interest. You could actually write a compound interest formula and function that just does a calculation, returns the value, and then in another function you could be asking, or your main function, asking for the time span and all of that. You could basically call that function multiple times, just providing a different time span. So you don't have to duplicate code. And that's one of the big uses of a function, is to allow us to take some code that we would normally have to type 3 or 4 times because we're using it multiple times in our program, and create a little abstraction bubble around it. Say, oh, I just want to call this formula. It takes this many values to do its thing, and I'm going to have it return a value. And that means that you only have to write that function down once, and you can just reuse that by calling that function multiple times. The other way we often use functions is really just to help organize our program. So we can break up a complex program into simpler parts where each function does a specific step of the process. In fact, sometimes you'll even see functions that are named step 1, step 2, step 3, because they're just being called in order. And that can just be a great organizational tool when your programs start getting too big. So those are kind of some of the ways that we often use functions. And hopefully this idea that these parameters are basically just variables that exist only within that function, and their value is set by whatever we pass in when we invoke the function, are going to carry through. There's one other thing I really want to show you here. This input, you know, is a function, and it returns whatever got typed at the command line. This float is also a function that converts a string to a floating point number. And notice that we just passed the result of the input function. So this input will actually return a string of whatever was typed at the command line. So we replace that with that string, and then this float gets called on that string, which then gets replaced with whatever that string is converted to a floating point number, and that's what gets assigned to A. So we can also nest function calls like this, one inside another. That's a common technique that you'll see as well. And in fact, we could even take and not have A and B as variables. If we wanted, we could take this entire float and input and nest it inside the sum. But then, of course, we wouldn't be able to print them down here. So how much you want to nest is really up to you. If you're not comfortable with nesting, you can go ahead and actually split this up. We could say A, and then A equals input, please enter a number, and then AA equals float of A. You can break it up into multiple steps that way as well. There's lots of ways you can do a program. There is no right way. This is actually something that came up in some of the discussions earlier of what is the correct solution. In programming, correctness means basically one thing. The program does what it's supposed to do, and then it stops running. That's it. That's the entire definition of correctness if you want to get into the formal definitions of correctness in computer science. So there's a lot of different ways the program can do what it's supposed to do. For the purposes of teaching a class, sometimes we steer you towards a particular method we want you to use, a particular approach. But honestly, as long as your program does what it was supposed to do, it is a correct program. That's one of the things that can kind of be hard for people to wrap their heads around after being so long in the K-12 education system, where oftentimes we have a very terse idea of what correctness is, that there is one right way to do things. And that comes from a lot of philosophy that's gone into education over the years that maybe is not the best for the modern world, because we know there are often multiple ways to get to where we want to be, and we need to be embracing of those ideas, which computer science tries to do very much. But that's one of the challenges of both teaching and learning computer science, is you have to break out of that mindset that there is one right way to do things, and be more embracing of the idea that there are multiple potential solutions, and that each solution has a potential trade-offs compared to other solutions. But there's not necessarily one that is best or worst. It really just depends on the context, how you're doing it, what your goals for that program are. So hopefully that clears up some questions. If you have more, please go ahead and ask us on the discussion boards. We are happy to jump in and do as much of this as we need to do. We want to bring you guys along. And thanks for your time, and have a wonderful day.